Hello students, today we are going to study ionization of acids and bases. So we'll be seeing here how acids and bases are being ionized to give the products, okay, and which type of product we are getting, okay. Like if we are taking hydrochloric acid, okay, you all know hydrochloric acid is a strong acid, okay. In the presence of water, what happens to this HCl? Okay, this H cleaves into H plus and Cl minus ions, and that H plus ions gets attached to this water molecule to form what? Hydronium ions. And what is being released out? That is chlorine ions, okay, or chloride ions we will say, okay, chloride ions. So when we are saying this, chloride ions are a what? Weak base. So here we are seeing from a strong acid we are getting what? A weak base in the product side. Okay. Now if we are taking a weak acid like CH3COH, acetic acid, okay, in the presence of water, naturally it is also ionized, but you all know now that yes, it is a weak acid, it is partially ionized. So H plus ions is released, okay, and it forms H3O plus ions, that is the hydronium ions, and what is released out? CH3COO minus. And this you will be seeing here, this CH3COO minus, this the acetate ions are what? A strong base. So we are taking a weak acid, we are getting in the product side what? A strong base. Okay. Now if a weak acid is used, okay, and we are using OH minus ion means strong base, okay, we will be getting H2O, that is water, and acetate ions. In this we are seeing what we have taken. We have taken a weak acid over here, okay, but which type of base we have taken? A strong base. So we are getting a weak acid over here, okay. Water actually itself, it is ionized as H plus OH minus ions, okay. So here we are getting a weak acid. So from strong base we are getting a weak acid in product side. Here we are taking a strong acid, that is HCl. Water is acting over here as what? A weak base, okay. And here we will be seeing that from this weak base, okay, we are getting a strong acid, like that is H3O plus ions, because here this is what? A weak base. Same reaction over here. Here one is acting as acid, the another one will be acting as what? Base. Okay, here water is acting as what? A weak base. Okay. So now we are going to study ionization constant of water and its ionic product. Okay. It means the ionic product of what? Ionic product of water. Okay. So we have seen that yes, if we are taking an acid and if we are taking a base, okay, here one acid has been taken, water has been taken in the form of base because this is acting as an acid, second one will be in the base form, okay. So now we will be getting what? An acid and a base, okay. So here we will be seeing what? This acid and the base, we are seeing in this what has happened. This H3O plus now has become a conjugate acid, because here you will be seeing from the acid what has happened. This base has been formed because here you can see H plus ion has been removed. So we will be seeing here this base which is being formed is known as a conjugate base. Here with H2O, H plus ions have been added to form what? A conjugate acid. Okay. So likewise, if we talk about water, we all know that yes, it is partially ionized as H plus and OH minus ions. So it can be act as what? Acid as well as a base. So if we have taken water plus water, okay, they have the property to exist in the form of both acid and base, okay. So if we are taking water and water, because we are going to take out what? The ionization constant of water or ionic product of water, okay, we are getting what? H3O plus plus OH minus ion. So when we are getting H3O plus, it is what? A conjugate acid. And if we are getting OH minus, it is a what? A conjugate base. Okay. So here, if we want to take out this ionization constant, okay, so here we can write K, and you all know how we take out this constant, equilibrium constant. Like that we will be taking out ionization constant also. That is what? The sum of the products, isn't it, upon what? The reactants to their coefficients in the power raised, isn't it? So here we will be seeing what? The product is H3O plus and OH minus, okay, and below that it will come what? The reactants, okay. Reactants is what? H2O, okay, that is in this is H2O square, because H2O plus H2O, okay. Now what happens? We will be cancelling it. Why? Because its value will be 1. Why it will be 1? Because here it is existing in its elemental form, okay. At room temperature it exists in the form of liquid. So what will happen? Its value will become 1. Okay, so anything divided by 1, the value will be only of the sum of the products. So now we will be writing what? W over here, ionization constant of water is equal to what? Because we are taking out the ionization constant of water, okay, is equal to what? H3O plus and OH minus. We will be taking out the sum. So experimentally we have seen that at temperature 298 Kelvin, okay, H plus ions have the value of 1.0 into 10 to the power minus 7 m, that is the molarity or the strength we can say. And in this, if H plus, here we know that yes, H plus ions is equal to the OH minus ions. How much H plus ions will be there? OH minus ions also will be that much only. Okay, so here also value becomes what? 1.0 into 10 to the power minus 7. Okay, so both are having what? The value 1.0 into 10 to the power minus 7. So now we can write here ionization constant of water is equal to what? This whole square, 1.0 into 10 to the power minus whole square, because both are same only. When we square it, we get 1.0 into 10 to the power how much? First it was 1 minus 7, square it will become 1, how much? Minus 14. So our value becomes what? 1.0 into 10 to the power minus 14 m for the ionization constant of water. So value of ionization constant of water is 1.0 into 10 to the power minus 14 m. So now we are in a state of identifying whether it is an acidic substance or a neutral substance or a basic substance, isn't it? If H3O plus ions are greater than the OH minus ions, naturally that substance will be what? Acidic in nature. If this H3O plus ions is equal to the OH minus ions, what it will be? It will be a neutral substance, isn't it? And if it is a basic substance, here H3O plus ions will be less than the OH minus ions, and those substances will be what? Basic in nature. So pH scale, okay, you all know what is pH, isn't it? Is the what? Power of hydrogen ions, isn't it? And this determines whether a substance is what? Acidic, basic or neutral in nature. Okay, so now we are going to see what? pH of water, okay, how it has been calculated. Okay, so pH is equal to, the formula is there, minus log base 10 in the bracket concentration of hydrogen ions. Okay, so experimentally initially we have seen that H plus ions is equal to 1 into 10 to the power minus 7, isn't it? Right now we have seen. Okay, so now we can put this value over here. So when we put this value, so pH becomes minus log in the bracket 1 into 10 to the power minus 7. That is the concentration of the H plus ions. Okay, now then when we derive it through log, pH is equal to what? It becomes minus log, isn't it? 1 minus log 10 to the power minus 7. Okay, so here what will happen? The value of this log 1 is 0. Okay, it will be cancelled. Okay, so now log 10 to the power minus 7. What happens? Minus sign over here, this minus sign only. This we have just brought it into the left hand side. Okay, and log 10. Okay, so now what happened? Minus log 10 is equal to the value is 1. Okay, with this all you can know by seeing the logarithm table, and you have to learn the method by which you see the log and anti-log. Okay, and that I will be providing you, okay, in the next video. Here minus into minus is equal to what? Plus, so it becomes what? 7 with a positive charge, no need to write. Okay, so now we can take out that yes, pH of water is, value is 7. So here, if any acidic solution is there, it will have the pH less than 7. You all know water is neutral. So we will be taking this as a marking unit for the acidic and basic solutions. Okay, so yes, for the acidic solution pH is less than 7. Okay, for basic solution pH is greater than 7. Okay, and for neutral solution pH is equal to 7, that you have seen for water, isn't it? For basic it will be more than 7 means what? 8, 9, 10, 11, 12, 13, 14. Okay, here less than 7 means what? 1, 2, 3, 4, 5. Okay, so this is about the pH scale. So now taking the same equation of the ionization constant of water, Kw is equal to what? The sum of hydronium ions and hydroxyl ions, and that is the value comes what? 10 to the power minus 14. You know this, okay? So now when we see this equation, okay, just we feel or we can see that if we put minus log over here, okay, then we get the pH, isn't it? If we add minus log over here with the hydronium ions, we get the value of pH. So let us move in that direction. Okay, so what we are doing, we are just here we are seeing everything, this also, this also, this also, we will be just multiplying with minus log 10. Okay, so minus log 10 Kw is equal to minus log 10 hydronium ions in the bracket minus log OH minus ions in the bracket. Okay, so when we will be solving it, we will be getting what? For this, when we are seeing, and for this we are seeing hydronium ions, okay, and this, we will be getting how much? Minus log 10 to the power minus 14, isn't it? So if we are getting this, naturally in the same manner we have done, taking here minus is there, minus 14, okay, log base 10, we all know the value is 1, so the answer comes now what? 14. Okay, so pKw, okay, here now becomes what? pH plus pOH, isn't it? So, and the value of this pH and pOH is how much? 14, isn't it? Because we have got here the value, isn't it? Now, so from this we can say that yes, if pH is 7 and pOH is 7 in case of water, okay, so pKw will become how much? 14, you add it, okay. So in case of water we will say that yes, it is 14, but when we take this for an acid, ionization constant of acid and ionization constant of base, we will be writing pKa and pKb, okay. Now this ionization constant, it changes with temperature, you all know, isn't it? That yes, this ionization constant of water changes with temperature. If the temperature is varying, here we will be seeing that yes, pH should be varied, but here it doesn't vary so much, okay. If it is there also, it is slight only, so we can ignore it, okay. Here actually what happens in this ionization constant of water, actually it is in aqueous, it makes it aqueous, thereby just maintaining the positions of the H plus ions and the OH minus ions. So This is all for today. Good day. Take care.